just really shifting the focus and inviting anyone who wants to kind of learn about the past history of the Onex, where it came from, some of the design features, the rest of the product family from our company, Sonex Aircraft, to head on over to the archive section of the webinars and take a look at the previous webinars Charlie and I have done together. Basically have done one for the last couple of years, and that's what I invite you to do. This is really going to focus on some of the new stuff, and I'd like to particularly thank those of you joining us tonight that have put your faith in Sonex and gone ahead and purchased a Onex and our current builders. I think there's going to be a lot of great information for you, and for those builders that are considering the Onex, hopefully you'll get all your questions answered tonight, and if not, you'll feel welcome to contact us at the factory and get them answered there. So let's get to it. We've referred to the Onex as, well, let's step back, the whole Sonex family as being the affordable kit aircraft, and we like to call the Onex the more affordable. And the reasons are these two slides, or this slide particularly with the folding wings and the single car garage in the background, really taking what we consider to be the higher costs of aviation and trying to work those out from this design. So why are we looking at a single place airplane? 90% of the flying is solo. There's fewer parts in a single place airplane because it's smaller. Because it's smaller, there's lower construction time. Because of the lower frontal profile with the same horsepower engines, you get better performance. And obviously smaller means it's easier to store. So we really have seen the market respond to this aircraft in an extremely positive way, and we expect the market will continue to once word spreads about the kind of performance and the kind of features that the Onex has built into it. Just going through the specifications, this is also a rehash of what you've seen before on these webinars. Nothing's really changed. I will discuss one change that we have made to the wingspan, and that basically allows you to build a short wingtip or a long wingtip, and I'll explain the reasoning and kind of which way you may want to go a little bit later. The length is fixed, 16.5 feet with 78 square feet of wing, which could be plus if you go with the longer wingspan. The empty weight of our prototype aircraft have been 560 and with the tri-gear 580 pounds respectively, and we'll go through those in detail a little later. The max gross weight at 950 pounds, which allows for a fairly large individual to get in this airplane and fly it. 80 horsepower AeroVee engine with a 15-gallon fuel tank. The Sonex has a 16-gallon fuel tank, so you're not paying much of a fuel penalty. Therefore, that's where the longer range comes from. Stall speed of clean stall of 45 miles an hour. The VNE at 216, higher than the Sonex, obviously. And our design limit, that is an incorrect 850. It's actually 950 at +6 and -3. So here's two of the more fun slides that, again, you may have seen previously in my presentations to Sun and Fun or the AirVenture Fly-In or in a past webinar. But this one really tells the story about affordability, how not just the option to go to your garage at home, but also the option to fully utilize a T-hanger. So here you can see 5 Onexes that are actually quite comfortably stored in a medium-sized T-hanger or a standard-sized T-hanger that you'd find a 172 would fit into. And then for fun, on our way to Sun and Fun last year, I did a bit of a study to see just how many Onexes we could fit in just the flight center of Sonex and the R&D center. So those of you that have been to our facility, this would be where the workshops took place in the flight center, and this is where we do all of our research and development. You can see 42 is the actual answer of how many Onexes you can comfortably, well, comfortably would be a relative term, but that you can fit. So just a fun visual of what we've got going here. Onex is Sport Pilot compliant. You know, whenever I look at designs and think about a clean sheet design particularly, I'm really focused on sport pilot eligibility. I think not just for anyone out there that is in the aging population or has had any kind of medical issues in the past that would prevent them from a regular ticket, or perhaps more importantly, for some of the younger generation getting into the sport for a simpler set of rules to be able to fly. We feel that's critically important. And these are just the highlights. The max gross weight we obviously make comfortably with the Onex. One occupant, so we're good there. Clean stall speed of 51 miles an hour. You just saw that on the previous slide, which now has been flight tested. And maximum straight and level airspeed of 138 with our little 80 horsepower engine, the AeroVee, going at 2,800, 2,900 RPM in a cruise setting. Comfortably make that. Fixed landing gear, single engine, and we use fixed pitch propellers in the Onex, so we're good there. And now to get to kind of the meat of the presentation, I wanted to talk a little bit and step back just for a minute on overall flight handling. And the Onex shares a lot of common elements with the Sonex, YX, and Xenos family of aircraft. And I think one of the most important, and one that we've become quite famous for, is the ease of flight and handling of our tail dragger aircraft. They are extremely sweet to handle in the most critical phases, which would be the transition from ground to flight, and then back when you're coming in for a landing in a landing configuration, set it down nicely. The big keys to that handling, or one of, and I think the most important key to that well-deserved reputation for being a sweet aircraft, is this direct steering. And when we talk about direct steering in the tail dragger, you got two pictures here. One is obviously in the back of the airplane. That's over here. We're looking at the tail wheel. And it's a very simple mechanism that the tail wheel pivots on. This is what we call our tail wheel caster, which moves basically in this direction. It pivots on this bolt. And then we have a little, what we call our pivot, which is just a sleeve with a bushing on it that's welded, mounted to our tail spring. And then we have our direct steering link, which is not a spring. You can see it's a direct steering weldment with a bolt, clevis bolt at the bottom and a clevis bolt at the top. And those of you with observant eyes can see our #1 prototype, which this is a picture of, 111 November X-ray, has a couple different holes up here in the rudder horn. And that's because we actually flight tested a number of different positions of this direct steering link to get that sweet feel in transition and have it feel about like our Sonex does, the right amount of input between the rudder and the tail wheel. And we found this has been a great success. You can see a little rudder trim tab, and I'll discuss that in a little bit, very important with P factor. And that's that rudder trim tab. The visibility of the tail dragger is also very important, and when we get to some of the shots of the cockpit, we'll talk about that. The Onex enjoys some excellent visibility over the nose, and then with a little bit of an S-taxi right to the ground. So that's a great advantage. And let's talk about P factor when you first go to apply power. And this is some of the guys out there that have 3300 Jabiru powered Sonex YX know exactly what we're talking about. When you go to first apply power, you got to be ready on the rudders to be able to put in input and counter that P factor. And that's what this little rudder trim tab is there to give you a little reminder when you go to accelerate that, oh yeah, I better get on the rudder here and keep things going straight. And you know, as far as pilot workload is concerned, you don't have the spring that gives you a delay between, or a series of springs that gives you a delay. So it's a direct response. And I find a fairly low workload for those of us that are interested in a sweet handling aircraft. And now when we go to the forward end of the aircraft, so we've covered kind of the back end, and then you can see the rudder cable going forward here, and just behind the rudder, the other rudder cable comes forward. Here's the other end of the rudder cable after it runs over a couple of pulleys. And we have a direct aluminum link that then gets bolted to the side of the rudder pedal. And then we put in some little springs on both sides. And those little springs just attach to this top bolt on the forward mount. That provides a little bit of feel for the rudder system. So again, you don't have to be stepping on the rudder pedals. And I'll be honest with you, after flying the tri-gear Sonexes, I start to get a little lazy on the rudder pedals, and it's good to have a little reminder every once in a while on that handling. And let's transition over to the tri-gear and have the same conversation. You know, the same reasoning applies why we want this direct steering. You know, a lot of tri-gears that you see out there, and perhaps the tricycle gear aircraft that you've trained on, have a free castering nose wheel. And a lot of those actually rely on brakes to steer. So you would actually have to step on the right brake to actually go right. That makes absolutely no sense to us whatsoever as practical designers of aircraft. What we have instead is this is the nose strut coming up through here with a spring, and that you'll see the tire would be right down here if we panned out here. And then we have a weldment at the top with a link. So this is bolted to that nose strut, and it moves at the same, obviously the same ratio as the strut. And it comes back to a little link. And this steel link has two springs on it, one here and one here. And it bolts directly to a cable that comes back through the firewall and bolts to that same link, that same aluminum cable adjuster on the rudder pedal. Now we use springs here, but they're very high tension springs. These are actually door closer springs for screen doors. And what they do is allow us to have a good amount of tension from here to this front link and from here around the bend. So you kind of have an endless rudder cable system with these two springs in them. What I really like about this is again, the same reasoning of the tail dragger. When you go to put in right rudder, you immediately get a right input on your nose wheel. And the same goes for the left rudder and left nose wheel. So we don't rely on brakes. We only use the brakes to stop. And very rarely, if ever, will you have to service your brakes. And another nice little offshoot, you can go with mechanical brakes on these Onex series, which is exactly what we've been using for years on the Sonex series. You save brake wear, you go to a less expensive, lighter brake system, and you use your steering cables for what they're meant to be, which is to steer the aircraft right or left. Makes for a real sweet airplane. Same thing in the tri-gear. We have the same rudder trim tab on it. The visibility is excellent because now you're in a higher position. The nose wheel is up off the ground. And all you really have to do as a pilot is on the tri-gear, just make sure it's pointed down the runway. Just keep it going straight. And this is just a picture. Again, I wanted to talk a little bit about pilot workload and how we've worked really hard to kind of take those intimidating aspects out of flying. We've already talked about the rudder pedals or rudder cables. Those are coming right back through here on the right and left. And there's your rudder pedals with no crap in there, no stupid hydraulic rudder pedals or anything else to deal with. You have one brake, and that's just a mechanical brake handle, which is located, actually the red is the brake handle right here. So as far as the steering system, that's all you got. You got a couple of rudder pedals, some direct links forward and back, depending on whether you're tail drag or tri-gear, and you got yourself a brake handle to stop. And we even put a little bolt in here for a parking brake. As far as the rest of the pilot workload, you got your stick right here in the middle, your control stick, which in this configuration, I've got my right hand on the control stick all the time, which leaves my left hand free to work this left quadrant over here. And your left hand at any given time, you're going to first obviously turn your master switches on, get everything fired up. And then you're going to move over to the mixture control. Make sure that's full rich before you hit the starter. You have your left hand free for the trim, the throttle control, the brake, or the flap. And very rarely, well, in fact, never will you need it to work more than one of those devices. So it's a real simple way of setting up a...
Back up on this slide, that would be great, Jeremy.
Yeah, this is, again, to give the bullet points, this is back in August.
Looks like we got to go one more slide. Sorry,
okay,
Jeremy.
One more slide? Sure. We're talking about...
I got about half of this one.
Okay. Workload in the flight handling, and I started back at that point with the actual rudder pedals and talked about how the steering itself, the direct steering, was tied to the single brake lever. And where I continued on with this slide was talking about the control stick in the center. So that's your right hand, if you're a right-handed pilot. And by the way, for you lefties, there's really nothing keeping you from moving all this stuff over here. It can be done with some modification of parts. But in any event, right hand on the control stick, which leaves your left hand to manipulate the flap control, the throttle, the trim system, the mixture control, any of the control switches, or the instrumentation if you need to make some changes, or the radio even if you don't want to take your hand off the stick. But as far as flight handling overall in the Onex, it's definitely a neutrally stable aircraft, just like the rest of our family, which means you take your hand off the stick, nothing will happen. It'll keep on flying along. You hit a bump, it might start to turn a little bit. You hit a heavier bump, it might start to turn a little more aggressively. So you fly the airplane all the time, and you keep your eye on that. But anyway, in the way the control setup is, it's a very simple cockpit. There's just not a lot of controls to manipulate, and your left hand, again, is free to do kind of one at a time for that column. In this slide, I was actually talking about the flight testing that our friend Roger Tanner, again, whose father Perry is building a Sonex aircraft. But Roger was kind enough to come in and help us with our some of the more aggressive flight testing. He built a checklist of maneuvers from Part 23 himself. And Roger, for his day job, his full-time job, and his paying job, by the way, is an F-16 flight test pilot out at Edwards Air Force Base, and a remarkable pilot in many ways. He has come out and took the airplane back in August through a stall and spin series. He was very pleased with the handling and performance of it through that series. He also did some unusual attitude maneuvers, some other aerobatic maneuvers, and it came through with flying colors, basically. And he plans to come back and continue this flight testing, and we are making the aircraft available for him to do so, and look forward to continue our work. And I'm learning a tremendous amount from Roger, again, in his professional capacity, and look forward to expanding my capabilities in this critical area. Flight testing, this is kind of cool. Again, you geeks out there are going to get very excited because there's a lot of numbers that we can pour through, and I have hundreds, and that's not an exaggeration, hundreds of spreadsheets already that have been generated from flight test data on our Onex series, along with our Sonex YX Xenos, turbo-powered YX, on and on. So it's really powerful stuff when we're able at every flight to pull things out like altitude, airspeed, VSI, and then getting into the GPS position data, GPS altitude, and GPS speed. So we don't have to rely on our what can be inaccurate airspeed calculations. We can actually base our performance data off of actual ground track data and ground track averages. So it's pretty sweet to be able to do these. And again, I just wanted to give you a little hint of what these raw data exports did. I just took a small sampling of our Excel spreadsheet data and dumped it on here just to kind of give you an idea of the kind of numbers that we poured through. And in doing so, and in continuing our flight test evaluation period of the Onex, we did publish the following numbers, and I wanted to just go through a couple of them. The two main numbers that people were really waiting for was this cruise speed number at sea level, 135 miles an hour, and those that you check the Sonex specs, you see it's 130. So as predicted, you know, the average speed increase of a Onex is between 5 and 8 miles an hour over a Sonex. And again, that's based on the kind of conservative numbers we like to publish at Sonex, based on actual flight data. And the cruise speeds here we published at 155 miles an hour. Again, 5 to 8 miles an hour is the rule of thumb. Somebody who takes a lot of time with their Onex to really clean it up, clean up the edges, fair in some things, we'll definitely see a little faster speeds. But those are the two main numbers I wanted to point out here. Again, the gross weight of 950 pounds with the +6 and -3. This is the most updated slide. And the useful load we have here at 350. And I'm going to discuss how that breaks down here in a little bit. But that's pretty awesome for a little aircraft to be able to haul that much and go that fast. The flight testing, and this is what again makes our flight testing pretty interesting at the factory, in that we have one of each of the bookends in terms of the Onex configurations. We have the tail wheel 111 November X-ray. This is the original 1X that I flew last January. It's the fastest configuration you can build for two reasons. It's a tail wheel aircraft, and it has the short wing configuration. So meaning from this split line here out is the shortest wing, the original wing. The other end of the bookend is our tricycle gear aircraft, and here it is, a very recent picture we took. It's been painted and cleaned up, and I've flown it a bunch of times since it's been painted, and it's just a sweetheart. But the prototype tri-gear is the slowest config. Why? It's a tri-gear, so it has this extra wheel out here. Instead of just a little wheel back here, it's got a big old wheel and strut hanging out front. So using our Sonex data, which we have, again, tons of data on the Sonex, we've said it's between 4 and 6 miles an hour slower due to just that extra tri-gear, a nose wheel sticking out there. Also, the long wing configuration. I'll take this time to kind of explain the wings and how you make that decision. When we get to the CG, we can talk about it a little more with a bigger pilot. But basically, this is the split line that I'm drawing here. On the standard 1X configuration, this is the split line between the fiberglass wingtip and where it meets the skin wrap, the metal aluminum skin of the wing. And this fiberglass tip has a 45-degree here at the tip, just like our standard, you call it a Horner tip, whatever you want to call it, a 45-degree cut. One of the most efficient wing tips you can find, by the way. And that 45, as it projects on this, would look something like that on the bottom of the wing, which leaves us basically this 1-foot section that can be cut by the builder. So if you wanted to go with a short wing, you would take this over to the bandsaw and you'd chop off 1 foot of your wingtip. And this would all slide in and your wing would end right about there. So it's kind of choose your own adventure as far as what wing. Why do you want a bigger wingtip? Sport pilot. If you are a bigger guy, and I'd say the cutoff would be if you're 220 pounds or more, you should seriously consider putting the larger wingtip on it in order to meet the clean stall speed. If you're a smaller guy, if you're 220 pounds, 200 pounds even, I would say you're very safe putting on the short wingtip and flying it there. Flight testing also, this is a debate we had internally with our design team about just how effective these 1X flaps were going to be. You know, that we're limited by kind of that 8-foot center section for where the wings folded. And what these 3 slides are meant to represent. This is a 1X with a 0-degree flap. You can see there's no flap down there hanging out. Here is what I'd call a first notch of flaps, or actually about a 22-degree. And this final slide shows how dramatic it is when you reach the 45-degree position. You can see just how much flap, and let me clean up the slide for you here. But you can see just how much flap is exposed, again, especially compared to this one where there is no flap there. It's pretty dramatic. The frontal shot, again, up at 22.5 and 45 degrees. I have seen regular descent rates with these full 45 degrees of flaps. Again, it's about a 3.5-foot section. Descent rates of plus 1,000 feet per minute. It's pretty awesome. The flat panel positions, this is looking inside the cockpit. In this slide, you're looking straight down. This is the main wing spar here. And so this would be forward of the aircraft that way. You can see the flap is in the 0 position. And this is the way we supply the flap detent bracket. This would be considered 0 degrees. And over here, this one would be considered the 45-degree or full flap. Now what we've done in our prototype, or this is in the tri-gear, the standard configuration in the tri-gear, this is a modified configuration which we put in the tail dragger. And again, you can see here is the 0-degree flap position, looking down on the handle. Here is the 45-degree flap position. And you can see this little center cutout. We've actually modified this little flap detemp bracket to do a 22-degree. I honestly do not feel this is necessary. But as we get into little customizations you can make that's not going to make my blood boil, this would be a great example of a reasonable modification you could make to just add a secondary flap detemp bracket if you just feel comfortable with not quite 45-degree flaps. Again, the flaps aren't anywhere near as big in chord as they are on the Sonex. That's why I think just a 45-degree is what you're going to want to do for proper flying. But here again is the side view in this slide down here of the zero would be here, 45 degrees, and then there's the little 22. Just to show you something fun you can do, customize your airplane. Whenever I give a webinar, I like to talk about the engineering of the aircraft because obviously a ton of time and energy has gone into what we consider to be the proper design and engineering of this aircraft. And I always like to show visually just the kind of rigorous engineering we've done with the 50-pound bags, which are all shown here, in doing them each section going outboard. You can see this is basically a 1X turned upside down with a support. That's that red block, and going outboard with these loads. And as we get outboard, you know, the more weight we put on it, the higher the simulated G loading as we go. And the visual representation of that is 10,200 pounds, which took our two biggest forklifts to be able to just hold the wing up. And you can see they're dropped down and clear in this slide. Showing that's a huge amount of capability for the airplane. It doesn't mean that you should get cocky and you should be overconfident with the engineering of the aircraft, but it certainly means if you operate this within the design limits and within the weights that we specify, you can sleep like a baby at night. The 1X tail has the same rigorous engineering associated with it, again simulating the actual air load that would be on the tail as we did a high G maneuver pull up or pull down. And again, that's what it looks like in a representation of weight in each of those sections as we work it. It gets really hard to be able to put the bags actually on the tail surface. But 1,730 pounds, and this tail is actually hanging on our wall. You can see the deflection at the tip was about, an inch and a half-ish, came right back when we unloaded it. So this kind of strength definitely comes with a penalty, and that penalty unfortunately tends to be a higher structural weight. So I implore all builders to be very mindful of the little additions that people like to make to their aircraft, but ounces turned into pounds, and pounds cut out directly the useful load that you have of the aircraft. So add things very cautiously. We'll get to that in a minute when we get to the CG, a little more on that when we get to the CG calcs. Engineering, it's always fun to talk about and physically show some of the cool form kit components that, again, we spent a lot of engineering time. In the Sonex, we supply what's called a Z channel, which is really just a piece of aluminum channel that's bent to shape, in this case a U section. And here in the 1X, we've actually taken it a step further where we did a laser cut blank with all the pilot holes in it. And then you can see a couple of tooling holes where we have actually formed this in a part press. And these make the verticals of the fuselage, the cross members of the fuselage, so suddenly you have a fuselage box with just clecoing it together. It makes for an extremely rapid build and a very, in my opinion, accurate build. Machined angle components, this is also something we've done. These happen to be options on both the Sonex and the 1X kits. But if you choose not to do the option, this is what you're starting with, just raw angle extrusion. And if you do choose this option, you're getting all the little machined holes cut, and it's all machined to shape. And these even have a beautiful finish on the edges. So very minimal filing and things to do the final finishing. And they all come with their part numbers, so you know exactly where they go. The assembled wing spars, same thing. You know, in my opinion, the wing spar assembly and the riveting is really more of a intimidation factor than it is a skill factor. With the proper setup and the proper confidence, you can do really well with your assembled spars. But this shows you, this is actually in our shop, which you're welcome to come check out anytime at our flight center. but this shows you the level of detail of the assembled spars with all the solid rivets installed, and I just clecoed on the ribs in order here, which went very quickly. And just another shot of the outboard spar, or what it looks like if you choose that option. Now we'll get to weight and balance. You see this is, again, last year, just before the first flight, when we did the first weight of the Onex aircraft. And probably the most common question, and this is, believe it or not, related to the CG calcs, or the weight and balance calcs. Will I fit? Well, there's a couple things. Number one, you need to fit height-wise, and this is Drew, who's just a little over 5'10", just shy of 6 foot. He's long in the torso, and you can see we took a picture here of him with the standard seat and the 1X. He's got a lot of headroom there, and you can see here this is the close-up where he's got at least a couple of inches of headroom above him, and it's very, very unusual now that somebody does not fit in the 1X. But we always say you got to try it on. It's the only way to know for sure.
Jeremy, how much room do you need to allow for hair?
That's why we chose Drew, obviously, because we can really show the top of his head. He'll love me for that. Sorry, Drew. But here's some specifics, and I heard from a guy after the last webinar that he was actually freezing the webinar and trying to zoom in on some of the weight and balance numbers. So I'm going to step through this a little slower this time, so you guys can actually see them. And you're welcome to email us for these notes if you'd like. But the aircraft, the Onex 111, the first prototype tail dragger, our CG range is 20 to 32%, and these are the actual digital scale numbers from the painted and finished aircraft. And there's the 584 pounds of weight. Those of you familiar with weight and balance calcs, you can step through here. We ended up with a moment of 35,424, and there would be the location of the arm. So down here I'm simply running that empty CG calc through, and I even added some weight if you did not use the NKET cylinders, if you just went with the standard AeroVee cylinders, putting you just under 600 pounds and about 17.9%. There are what the arms look like. So as you consider, the other factor of the will I fit is here's you, and here is your theoretical center of gravity at a 78-inch from the forward datum. So when we talk about who can fit, not just physically but also weight-wise, I like to show this slide. Here is me. So again, I used the aircraft as it sat with NKET cylinders, 584 pounds with that moment. I added full fuel, so it's 15 gallons of gas, and there's me at 160 pounds for a total weight of 828. So I end up flying in a solo condition with, well, obviously, but in a full fuel condition of just under 24%, which is great. We're looking for 20 to 32%. So I'm forward CG, and I'll theoretically be pretty fast because I like that CG forward. And then we look at the only other condition on the 1X you really have to look at is, again, empty aircraft with low fuel. So here we just have a little over a gallon of gas, gallon and a half of gas. Me of 160 pounds, and now we drop to 754 on the weight, and we end up at just under 27%. Gorgeous. So it's really hard for me to get the prototype 1X out of CG range. As we look at a heavier pilot, which I know most of the listeners today are heavier than me, the aircraft, your pilot weight would plug in right there, 250 pounds, and we'd operate at a 938. So up to 250 in this scenario, and we're flirting with baggage and full fuel with that limit, with the 950 pound overall weight limit. And here we are, 28.4%. Cool. A little further aft CG, but you're in good shape. And now we have that same pilot with a little low fuel condition. So as you've gone through the flight, you've burned your fuel away. There's your total weight. There's your total arm. And it calcs to just under 32%. So again, a 250-pound guy with a tail dragger is going to be hard-pressed to take this out of CG range, which would be after 32%. Now we move over to the tri-gear. And again, this is the actual weight and balance numbers from our tri-gear. I pulled this right out of our book. Empty weight of 225, 229, and a nose wheel 139. So as expected, the tricycle gear, even with the NKET cylinders, is heavier. But again, keep in mind this is with the big wingtips, and it's a fully painted aircraft. So that's where the weight's going to come from. 593 pounds. At that moment, we run it through the same numbers, and the empty CG of the tricycle gear, as expected, is a little further forward at 19.5% because, again, we have the nose wheel weight up front. With the tri-gear and the Onex, you basically just add the nose strut and the rest of the stuff forward. And here are how those arms translate. Here's you again, the pilot weight. And here's your theoretical CG from the datum. And you can notice this is basically where we've added most of the stuff for the tricycle gear configuration, and then we've slid the main gear back. So it was here in the tail wheel, and now it gets turned around and slid back. 593, 84 pounds, and me, again as a pilot, I'm flying at 837 at 23.6%. Beautiful. Again, 593, 10 pounds of fuel, so we've burnt all our fuel off, and still me as the pilot, and I've migrated it back to 26.7%. So, rough numbers, you're going to migrate with fuel burn about 3% through the range. Then we have the heavier pilot scenario again, up to 250-pound guy in the tri-gear. What are we watching here? We got baggage and full fuel, and we're still at 593 for 947. So long as we keep it under that 950, we're happy. And that CG would translate to 28.37, further aft than me, so I'll probably be faster. But that's about the only advantage I would have. Again, with fuel migration, we're looking at 10 pounds of fuel, 873. And a CG with low fuel of 31.4%. So that's the real quick and dirty way of looking at the low cases. It's going to be really hard for anybody to fly these things out of CG unless they make some fairly significant changes to the aircraft, which I obviously implore you not to do. Wing fold transport brackets. This has been a common question, kind of shifting gears now on some of the utility of the aircraft. And you can see these are something people have been asking about. Can I do some kind of locking bracket that I can, once the wing is folded up, put in place and kind of retain the wing for transport? So you can see we made kind of a fancier, Dad and Drew made kind of a fancy main inboard bracket here, made out of a couple of angles back to back with two spacers and getting the stack up the same as that center steel fitting with a pit pin in it. And the same for the rear here, just a single angle bracket with a pin in, and we're actually using the same main spar pins to go through these two brackets to lock them in place. We also even added a high-tech bungee system to hold the ailerons in position so those aren't out flapping around. And we actually got a chance to test these out. Those are the brackets in place with Carrie and Dad, rolling it into the convention center here in Oshkosh. So we actually took it across town, and you can see how much room we have here. This is designed for like boat shows and stuff. But we made it quite easily and comfortably into this convention, and we got to show it off to the local businesses in the Oshkosh community and test this feature to boot. Another important note, so here's a little better look at that main bracket. And we will have plans for this. Trust me, before you finish your aircraft, you'll be able to download and build from plans this same bracket if you want to do it, or some variation because you're a home builder and you're creative. But you get the idea. 3 little bolts in the middle holding the stack up together. And then this, you just have a little aluminum piece to store. And an important note, we're looking at the bottom of the wing in this view. And these are the two inspection plates that can be easily removed. They just have little sheet metal screws in them. And you can actually get up and remove this main bolt. And what's powerful about that is if you're going on a long trip, and by long, I'm talking about, anything that you wouldn't want to compromise the rest of the wing on. Take a little extra time, remove these two panels, pull the bolt and a couple of buddies, and take the wing off the airplane. And now you're able to go cross country. You can drive to Florida and back and go to California, whatever you want to do, and not really risk any structural damage to the aircraft. So that's pretty sweet. I wanted to cover drawing revisions a bit. I know we continue to field questions about this, and a lot of it lies in the technology and using the technology and using the kind of features we built into the plans and the support. But here is the main website up here. I just did a screenshot of this just about an hour ago before I walked over here or drove over here. We did our Onex revisions, and on it you go to our support tab here on the main site, and you bring it down to do drawing revisions. And then you come to this page and you click on Onex, and this is what you'll see. And there's two types of drawing revisions that we regularly issue. One would be considered required revisions, and we say right there they have a direct impact on the construction process, and it's very important for you to make these. Then we issue what's called optional revisions. Now these are just mainly drawing cleanup and note changes. They might be a little different piece of hardware or a little view change that we don't think, maybe it's just cleaning up a confusing or common call. But I obviously invite you to make both of these. And here's some examples of when you scroll down on this same page, you would see this under required revision log, and you'd see a listing of revisions here. And I like to go through a couple of the features of these. We put the date that they're issued. So really all you have to do when you get your plans is note the date. And you're going to be able to know right away, just without going any further than the date column, which ones apply to you. So if you got your plans at the end of last year, yep, you better look at that one, and you better look at that one. Let me clean this up. If you got your plans last year, so let's say 1/1 of 2012, you know that one applies to you, that one applies to you, that one you already have made in the plans, and that one you already have made in the plans, so you don't have to worry about it. If you feel like it, you can keep going, and there's not that many revisions to go through, but it gives you the drawing number and what revision it applies to. So another hint is that if you have Rev A of C01 drawing, you know the revision that's NC doesn't apply to you. It tells you where to look on the detail or on the views. Tells you what's wrong. In this case, nothing's wrong. We just added some attached detail for the rudder cable springs. In some cases, we're going to put a downloadable link to a PDF, which you could go to our website right now or after this webinar and give this a test drive for those of you looking at the plans. But we're very actively pursue drawing revisions. We update this once a week lately. I personally look at all drawing revisions once a week or more, as we consider our plan set to be a living, breathing thing that we want to be current for everybody. It just makes everybody's life easier top to bottom. This is an example of some of the optional revision logs. I'll tell you when it was last updated. And again, using that same example, if I got my plans the first of this year, that one applies, and that one applies. So I better keep reading. I know which drawing it's on. I just happen to chop the top of this off. So all three of these are CO1 with the right rev letter, and what's located, what's incorrect, and what's correct. In this case, 2 bolts are too short. It tells you exactly what's wrong, so you better change those to the bigger bolts. It turns out, unfortunately, guys, that I am human, and I certainly make my share of mistakes, and I'm really pleased that we have this kind of infrastructure there to not only update it for the next guy coming along, but also take care of the guys that are out there in the field working now. Again, shifting gears to the AeroVee engine installation, because I know this has really become a perfect marriage between the Onex and the AeroVee in providing really reasonable performance at a very reasonable price. The engine installation, it's got the box baffle. It really, any of you guys out there with the Sonex Wax or Xenos can pull your cowling, and this is basically what you're going to see. And the only real different feature we built into the Onex, again, to keep the front of the cowling a little cleaner, or use that bigger opening in the front, was this top-mounted oil cooler. And I'll talk about that in a sec. But there are a couple of things, and we're going to be announcing these soon with documentation. Those of you Onex guys that have already ordered an AeroVee engine have already received these features, or just recently received some of these features. But the exhaust for the Onex, these are the same headers that a Sonex Wax or Xenos guy has. And they just happen, the Onex guys have shorter stubs, stub tubes that plug into those 2-in-1 headers with the springs, and they clear the firewall. The Sonex versions are actually quite a bit longer. So that's the first thing that's different with the Onex. On the next engine installation item, the intake manifold. We ended up with the intake manifold up here. In the Sonex version of this intake manifold, this stub pipe, or the bottom of the Y, actually comes straight down, which means this injector, this aero injector, would actually be mounted front to back. With this, we found, unfortunately, again, that human thing, darn it. But I found when we put these tricycle gear provisions, which everybody has, everybody that buys a Onex has their motor mount provision for this tri-gear nose strut, whether they put it in or not. We had to rotate the injector so it had some clearance here between the nose strut and the back of the injector. So basically you have a special manifold, and it is actually called, strangely enough, our Onex intake manifold. So we make sure that you're equipped with that. For that top-mounted oil cooler, we actually use a flat oil pump in the front of the engine. So we're actually looking right at the front of the engine, right under the cowl lip right here. And instead of that bypass type designed for an oil cooler that's mounted on the bottom of the engine, we actually just go ahead and put a straight oil pump. That comes standard with your engine, the Onex setup. And then on the top-mounted cooler, and some guys have been inquiring about this for their Sonex YX or Xenos, and that is the next step. We're putting this setup in a Sonex, and we're going to be testing it in order to confirm it. But for now, both Onexes have this installation. This is a little different top-mounted. This is actually the bypass area on the top of the AeroVee crankcase. And we designed and are supplying now this special adapter plate, which takes the cooler, the oil cooler, which typically sits going this direction in the car, and flips it over and pushes it back. And the reason we want it aft is we have our cowling that comes down on a slope like this. So we have to provide as much clearance as we can with that cooler. And then we developed this little baffle system, which will be part of the baffle system that you already have. Will provide the patterns, so you're able to cut these out and make that channel for the top-mounted cooler. Some other fun things you can do in customizing your Onex, and I know home builders just love to make things their own, and I do too. And obviously you'll find there's a lot of things that I think are fun things you can do and interesting things you can do to make it yours. And there are some things, structure would be a perfect example, that if you touch, I will not be so friendly. But in terms of making things yours, here's some cool stuff you can do. We're testing this ourselves. It's a new battery. It's very rare that you're able to save 11 pounds out of an airplane, 10 or 11 pounds. The batteries that we're currently using, this is in the Onex Tri-Gear, the PC545. The Onex Tail Dragger has a PC625 like this one. A couple different battery box configurations. This one's just got some straps with some piano hinge that run across the battery and over the battery. So this is where you can let your home building flow. You built a whole airplane, you should be able to design a nice carriage for your battery, whichever one you choose. But this is the Odyssey PC545, weighs about 13 pounds. This one from the AeroVolts guys, we're putting in and testing right now at a fraction of the weight, about 3 pounds. That's pretty awesome. Some other fun things you can do with upholstery. Yeah, you can. We're going to announce this tomorrow that it's available for the Onex. This should actually say Onex. I just did this before I came over here. But you can see it's just a simple seat back and a seat bottom, 1-inch cushion. And we also have a little baggage bag that we pre-sew and supply, so you're able to just put it in and put screws in the side rails and have it over with. So that's going to be a cool little option. I like to talk about instruments, and we could do an entire another webinar that's just devoted to our experience with instrumentation. But I'll tell the story with just a few pictures. Here's the Tail Dragger original Onex. Pretty cool, doesn't it? That they look almost identical, but they're two different airplanes. And here's 222 November X-ray. This one's got the little MGL flight instrument, the Extreme. It's got the MGL radio and a little G meter. And you can see here's the brake and the flaps and the throttle and the trim. And here's the Tri-Gear Onex, which has the same Extreme instrument. The radio and the G meter just happens to be up top. And the same thing, same control quadrant. And that's why I can so readily jump between the airplanes. And if I didn't have placards telling me which airplane I'm in, it would be a challenge. So now let's add another layer. Let's start looking at our other Sonex panels. And you can really tell why I need these placards in here to tell. But these are some other fun things you'll be able to do in your Onex. We have on the website a full-size EO1 drawing with your panel, which obviously the Onex panel just looks like that. But here's the Enigma, the full color display. Here's the radio. Again, center mounted throttle, but I'm not concerned with that. I just wanted to show you some of the instruments. And here the Ultra Flight XL, which is a black and white instrument all in one. And again, a little microwave radio in this one. That's the Xenos. Then we have the smart singles. So those of you looking for the most economical way to do it could go with these MGL flight and engine instrument, MGL flight and engine instrument. This happens to be in the Tri-Gear Sport Trainer Sonex, and this happens to be in the Sport Acro. Sport Acro has the center bucket seat in it in the Sonex, and you can see we even went inexpensive on the radio, just a little ICOM handheld radio, Icon radio, and you know, we even went with a actual G meter that's an old steam gauge. The antenna, we get a lot of questions about this, but with the Onexes, both of them, we just stuck the antenna on the belly of the airplane with a little isolator through the skin. I found it works great, you know, unless I have my back to the tower. Then it's the only times I have transmission issues. But 99.9% of the time, they hear me beautifully. Another big announcement to make tonight. We have official, it is official. The FAA has been approved by the FAA with 51% compliance. Not that it's a surprise to anyone, but this is the letter I received from Brian Cable dated February 10th. So this is hot off the presses. And I received it in a FedEx package today, and we'll be posting this to the website. And the FAA will be updating their website with the Onex designators. This happens to be for the all option kit, and there's a second one with no options. So obviously the all options would be with machined angles and assembled spars. The bottom line, it's comfortably in compliance as we expected, and there's actually a bit you'll be able to subcontract out if you want to. Here's a visual for those of you that haven't seen or haven't spent much time on the web looking at our kits. This is what basically the Onex kit would look like if you laid it out on the floor. This happens to be the Sonex kit. The only difference with the Onex kit is there'd be a lot more little pieces like this, that form channel and angle we talked about before. We'd have those on all sides of the fuselage and wing. But that's really tells the story. That picture's worth 1,000 words as far as what is supplied in the kit. Really focusing your skills on trimming and drilling and assembling. And here's a fun fuselage assembly. I had this on display at the booth at the air show last year. This is using all the Onex kit components, and you can see all these little knobs on here. And these are all the Clecos, the 3/32 temporary fasteners that I used to kind of put the whole thing together. I started at 10:30 in the morning, and I had this at about 1, maybe a little before that, maybe around noontime. So it took me literally 2 to 3 hours to get this thing completely together and assemble, including the vertical tail. So it starts to look like an airplane a lot. So those of you that struggle with motivation, the Onex is a real answer to that. You're going to have something that looks like an airplane in a hurry. This outboard wing section, same thing. If you do the assembled spars, which this is basically the assembled outboard section and the assembled inboard section here, you can see I just put Clecos through all the wing ribs. The root sections, got it all aligned and put it in, and it's already drilled. If you go with the spars, you can even put a little pivot in it and do your wing fold in just a couple hours. It's pretty fun, and again, very motivating. You can go almost right to the skinning stage. And there's a tail, and I did this also in a little less than 2 hours. Just laid out all the channels. Obviously I know these plans in this airplane like the back of my hand, but laid out all the ribs as a skeleton structure, and then started installing the Clecos in the skin, which really is your tooling. The AeroVee engine, we're obviously big fans. We spent a ton of time and energy in creating and refining this kit, and all the Sonex WAG Xenos and other aircraft builders that have been installing this engine since 2001 have, we really appreciate your support and your business in this engine and making it the success that it is. One of the most successful aviation engines in the market. Really the attractive parts, kind of like the Onex, not just the upfront price tag, which looks very attractive, but certainly the ongoing maintenance and overhaul price tag is impossible for anybody else to compete with in this world. We just have the fully forged nitride crankshaft and one of the simplest and most robust propeller hub designs. We refined all the red machining parts, which really look like little jewels when you go to put them together. Have something that looks like it was made for your Onex. Another note, obviously, we do the fully assembly manual, which is a step-by-step guide, just like your Onex plans, and an assembly DVD, which I invite you to order this if you wanted to check it out. I think we sell this for 25 bucks, and you get that money back if you order the kit. And it's a fun watch for those of you. Again, I think it's more of an intimidation factor in putting your own engine together more than anything else. And get a group of guys together. Certainly make special note of who your local engine guys are and who the guys are that like to work on their street rods. Those are the guys you want over helping you on this engine. Make short work of it. The workshop series, I'd just like to formally invite all of you to our weekend workshop. It's been a tremendous success here in Oshkosh. You get to come visit the EAA Museum and then pop over to our factory, a 2-day workshop. We've even published the 2013 schedule. And please note, we're actually shifting some of the dates, but we just held our 50th workshop. So we've done this a lot. And you can see we're doing it first weekends in May, October, and then next year we shift to March, June, and October for 2013. And I'll wrap up with this slide. This is really a visual for those of you that are like, okay, all sounds great. What's my bottom line? Well, here's your bottom line. I get to put my salesman hat on if I haven't been doing that already through this webinar. But yeah, this is a good comparison. This is the Sonex with AeroVee that we've been advertising and obviously has been the lifeblood of our business for years. But you can see about a $14,500 kit. As we run through the line items, the airframe is $14,500. The hardware kit is about $1,000. The engine is the same. So I'm just highlighting the things that are basically the same between the Sonex and the Onex. The firewall forward miscellaneous, we even put that in there. So we're talking about oil coolers and hardware and stuff like that. Instrumentation, we gave you a budget for $2,000, so that would certainly get you smart singles, a radio, some basic instrumentation, even a GPS. But if you start to go to some of the more exotic color instruments, bigger displays, data recording, that can certainly go up from there. They basically use the same propeller, and you can see in the Onex you save some money on the upholstery and you save some money on the kit. And actually, don't let this bottom line deceive you. They look pretty close. You actually get a lot more in terms of what is in the kit with this, and that is why we have that higher price. So then you can go across. The Sonex with the bigger engine is obviously more money. The YX is just a little bit more than a Sonex and Onex. And then we have the Xenos with AeroVee, which, hard to compete with any other motor glider in the market. I don't think anyone can touch that 33.5 for something with the utility of the Xenos. Ways to follow the Onex. We continue to be active and will continue to be active with all kinds of things to connect you to the Onex and vice versa. We want you to check the website often. The Onex has its own website at Aircraft Onex. We have the opt-in mailing list, which have been extremely popular. They're AKA the RSS feeds, but actually we have an opt-in mail list that you can subscribe to and just have a pop in your inbox. We don't do updates that often, so you're not going to be spammed. You're just going to get the important updates that you want to receive. And the email lists are very active, both the Sonex Talk and the Onex Plans, especially if you're a Onex Plans owner. Please join that group. For now, it is only open to builders as we get the product launched and get it off the ground, and try to cut out all the other chatter and just have these guys focused on getting questions answered. Come to a Sonex workshop. You already saw that previous slide, and please consider this your personal invitation. I didn't update that yet, but it's the end of July in 2012, so certainly come to AirVenture. Much more to come, guys. We're really excited about this. We feed off your energy. You know, after a long day of working on this airplane, it's just extremely gratifying to hear the kind of great comments coming in, and I know that'll just go up a notch as we get to hear about the flight experiences of those of you out in the field. This little guy is my son, Miles. Um, I'm extremely proud of him already, and now he's obviously a lot bigger than this picture, which was taken last year, but it shows what our company is all about. It's about the future. It's about the next generation. It's about keeping freedom of flight in place, and it's about keeping, perhaps most importantly, things affordable so we can all continue to enjoy these great hobbies. And I guess that's pretty much wraps up the presentation that I had.
Well, that was great, Jeremy. We had over 300 people with us tonight, which is always nice to see. A lot of questions about engines and whether you will support anything other than the AeroVee on the engine front.
Mm-hmm. I'll be happy to address that. I obviously brought you right back to the total cost worksheet. The reason we are so incredibly excited about the AeroVee engine is that line item right there. You know, in terms of looking out at the market, I just don't see anything else at that price point that delivers 80 horsepower that can do the kinds of things that we can do with the AeroVee. That said, we have a tremendously positive relationship with Jabiru. I really enjoy the simplicity, the elegance, the entire Jabiru team, both on the US side and especially in the Australian side, where they've worked really hard to improve the product. Again, just looking at the Jabiru, it's you know, a completed engine, but you get what you pay for. For the 3300, you know, you're looking at 18.5. So sure, it would be a leap in performance with the Onex, but it would also be a leap on the bottom line in what we're putting in this airplane. Granted, you'll be tough. You'll be running and gunning with the real big boys with a 3300 Onex. So I guess I hope I've been slippery enough to say, for now, we're committed to going forward the Onex with the AeroVee. There's no question that as other customers come on board and as the market continues to grow with the Onex, it may be logical to expand beyond just the AeroVee engine. But for now, it's just such a perfect fit in every way.
Okay, and the one thing that I observed on your cost sheet, Jeremy, was that what's not on that sheet is all the savings in the upkeep, the hangar rent that you're going to avoid by tucking it in with somebody else.
Put it on down there, right? Savings. I think I'll
Exactly.
do that. I'll do that for the next webinar, Charlie. That's a great idea.
Okay, and Larry'd like to know what about the Y tail for the 1X?
Yeah, it's a common question. You know, I personally really enjoy the look of the wide-tail aircraft, not to mention the handling, which, you know, this airplane and this airplane are basically the same airplane. But it really is a unique look. You know, I think it's a strong possibility, and I'll leave it at that. You know, it's a strong possibility to offer in the future. For now, if you're really anxious to get started and you really like what you see, go with the straight 1X. I don't think you'll be in a position to regret it, that's for sure.
Okay, and the Robert has a question about what's the current lead time on a full kit?
Yeah, that's a great question. Our lead time is typically at the Sonex factory. It runs between 10 and 14 weeks. That's pretty typical for the last couple of years how we've been running. Um, lately, it's been closer to 14 to 16. We've been very busy, which is great. Because we service a pretty large fleet of aircraft and a number of different options, you know, there's only so many airplanes we can push out during the week. So if you ordered today, the answer to your question is about 15 weeks. And if you order next week or next month, I don't know. I hope, again, we're working really hard to deliver on a regular schedule, not grow too fast. Very important, especially for those of you out there that run small businesses and understand the unique challenges we have as small business owners. We don't want to grow too big and then live to regret it. So we're being very logical about what we can deliver, and hopefully people can work with that arrangement. 1/3 deposit to start your order, with the remainder due just before it ships.
Okay, and Paul would like to know, has anybody tried to fly the IAC Sportsman known in the Onex? If so, what is their impression, and what is the anticipated fatigue life of the Onex if it's used primarily for aerobatics?
Mm-hmm. I'll break that answer up. Most of the routine has been flown, but to my knowledge, we have not. And I should know, we have not flown either of the prototypes through the series at this point. But given the handling and the similarity to the Sonex, I would fully expect it will do quite well. And you'll be able to read more about that, especially as our builders get up and running and start doing different things with it. As far as fatigue life of the airframe, you know, if you run it within range, sadly and depressingly longer than you. You know, the airplane with the 6061 T6 aluminum that we build out of, it is extremely long fatigue life and really good fatigue life. So it really doesn't become a consideration at this point. But obviously, you know, what you're paying us for, a big part of it is to monitor the fleet. And now with the Sonex, which is basically the same structure, we've got about over 14 years now of Sonex aircraft, 14, sorry, of Sonex aircraft flying, and they've held up extremely well.
Okay, and Stan would like to know, what is the difference in flight characteristics between the 20-foot wingspan and the 18 foot wingspan? And he's going to apparently already has his kit on order.
Great.
The way you explained it, he'll get the wingtip, correct?
Mm-hmm.
And
Correct.
then from there he'll get to modify it to his choosing, right?
That's exactly correct. It's decision time. You know, but the good news is, since you're just about to get your kit, you can wait a while to make your decision. So there's nothing that's dictating that you make this decision now or later. As I said, I feel the dictating factor for whether you go with, let me just get the slide pulled up here. In my opinion, the dictating factor for whether, two dictating factors. The first one would be what weight are you going to fly at? And I gave you that number of, if you're 220 pounds or more, I think it's a no-brainer. I go with this larger wingtip as it arrives. If you are, the other factor obviously is when the wings are folded up, if you put the long wings on it, and I'll try to get to that very first slide showing the wing fold, but if you fold the wings up, it actually sits with the short wings 7 feet from the ground. So the garage door you see in this picture, without even knowing the specs, I almost guarantee that is a 7-foot garage door. So factor number one is, what is your operational weight for the airplane to be sport pilot eligible? Let's make that important caveat. If you don't care about sport pilot eligible, I'd be very comfortable flying with the shorter tip. And again, the other factor, what space you're gonna keep it in. As far as performance impact, I think it's minimal. You know, I've obviously logged quite a bit of time now in both our tail dragger and our tricycle gear version, and there is not a tremendous feel difference, either in terms of roll rate, top speed, climb performance. Let's go down the list. But anytime, obviously there is some impact, and anytime you add wing area, you will slow the airplane down, number one. So a guy that has the configuration you see blasting over Oshkosh with the short wing tips and the tail dragger, and he took some time cleaning it up, is going to shoot right by the guy that's got the long wing tips, the tri-gear, and all the other crap that he's going to hang off of it. So, you know, just be mindful of those things. But and then roll rate, anytime that we add wing area, we obviously also decrease roll rate. So if you want the sprightliest feel you can build, you build the short tips.
All right, and Claude would like to know, are the instruments easy to see at the downward angle that you have to look at them?
Uh-huh. Yeah, this is, I would say this is not a fair, it's kind of blurry. I took a low res photograph and then I pulled it up to expand it to here. So this is not a fair representation of what you see. But you can easily get that when you come try it on. And no, it does not impede visibility. I find it to be quite comfortable. Obviously, not obviously. I have pretty good eyes. I had the LASIK surgery, so I can see really well. And these little color instruments don't bother me. The little display on the micro radio on the G meter, I can read quite readily. My father has complained quite loudly about the size of these, and so to my father, I would say, go with a smart single with some larger digits on them, or go with the big color display, which if we were to draw it on here would take up about that much of your panel. No exaggeration about there. And then you'd have enough room for your radio, and that's about it.
All right, and Clinton makes a statement that it seems like with a Sonex, it allows a lot more potential and flexibility. You can sit in the center if you like, but you have the longer wingspan and size. You retain the ability to carry two people, and he's struggling with the decision right now. Any thoughts?
Yeah, buy both.
Yeah.
All kidding aside, we recognized, and this is part of when we talk about our research and development programs, we're not trying to cloud the market here. I would answer the question, as I typically like to do, with a question, because I don't have the answer. But I will ask you, what is more important to you as a pilot? How important is having that second seat? And having that second seat, I agree, more utility. I agree, the Sonex airframe in terms of how many different airplanes you can build with one set of plans, it's mind-boggling. It's like 32 different airplanes. Um, but, you know, we again, coming back to the point, if you want a second seat, then build a Sonex. And if you don't, then build a Onex. I mean, I really think it's that simple.
Sure.
It's important. A couple other notes I really want to make here, Charlie. Uh, on the wingtip decision, you're not stuck either way. So if you decide to put short wingtips on your Onex, you can always buy a second wingtip from Sonex and add on to it later, or switch back and forth. You know, if that's a consideration, and you have maybe two partners, one guy that's 160 and one guy's that's 260. You really need two different, or maybe want two different configs. You can do that with this flexible airplane. And on the Sonex, I'm always remiss if I don't mention on the Sonex that the wings are removable on the Sonex Wax and Xenos. We do not advertise it as an easily removable or an easily foldable, but it is. If you've ever been out to the glider port and watched three guys take off these huge, 28-foot wings, you've got a little 12.5-foot wing panel that weighs 78 pounds. It's not hard to pull the wings off of Sonex and store it, especially for winter periods and stuff when you don't fly. So I always make that important point that the Sonex Wax and Xenos have removable wings. They just don't have the easily folding wings like the Onex does.
See, I was going to say that the most important thing is that if the spouse has to get a ride at some point, then that pretty much answers your question.
Yep,
And
absolutely.
if they never want to take a ride, then you can build a 1X, right?
How old's your son or daughter? I know
Yeah.
Miles is going to be chomping at the bit to have some rides, and it'll sure be nice to have a Sonex in the hangar for when he does.
Okay, Ben would like to know how long would it take to finish the kit?
Definitely one of our most common questions, and one that I actively dodge. So prepare yourself. I'm going to actively dodge. Um, it's all about you. It's all about you. I have had guys report real build times of a complete Sonex, which does not have the kind of design features that the 1X does, or more advanced, I should say, design features, kit features, uh, plus an engine, and get it all together in about 500 hours. I've also had guys with a straight face tell me I had over 2,000 hours of build time in my Sonex. So, it's unfair to me to say it's either extreme, but I will make a couple of absolute statements. Between the detailed set of plans with the Sonex and Onex and with the simplicity of the airplane and with the completeness of the kits and kit components and the thorough and always available technical and sales support, um, it's one of, if not the lowest build time kits out there. I don't think there's any question about that. Um, so really, it's about you, and if you're the type of guy who starts a project and then walks away from it and lets it sit and collect dust, then you're going to be one of these guys that thinks you have 2,000 hours in it, but you're not building all that time. You're doing a lot of head scratching, you're doing a lot of garage cleaning, you're doing a lot of gabbing. I really believe a realistic build time for these airplanes, and especially for the 1X, is going to be a 300 to 700 hour project. And any more than that, you're just wasting time.
Okay, Ryan would like you to expand a little bit more on the wing folding mechanism and the safety locks.
Sure. The wing fold mechanism, and I thoroughly covered this in our last couple of webinars, but the way it simply works is you have one handle sticking down out of the wing, and then you have two spar pins. I'm just looking for a good picture if you'll bear with me here. This one's as good as any. So the way the wing fold mechanism works, we've got one handle that sticks out the bottom of the wing, and that handle actually goes, grab my highlighter here, it sits right here and sticks out the bottom of the wing. On the bottom of that handle is a main spar pin that goes through right here, and that happens to be engaged in the bottom of this wing lock. On the top, you don't see it here, but is a little red indicator. And then through the center is a long push rod with a locking pin at the back. So when you pull this handle forward, you pull this pin out of the main lower pin area, and you also at the same time pull this pin out of the rear spar. So with one motion, you unlock two pins. Then at the top, you suddenly see a little red indicator pop up telling you, dude, you are currently unlocked. Don't go fly. Don't try to tow me. And then when, again, that's when it's unlocked. When you go to lock it again, it has a little retaining pin down here so that once you do bring it up into the unlock position, the retaining pin pops out and locks it in that forward position. Then you bring the wing down in place, and you pull that same retaining pin and push this handle forward. So therefore this pin goes into the rear spar and this pin goes into the main spar, and the retaining pin clips on the other side of the handle. And you have yourself a locked position. So here's the bottom of the handle right here. And that's what you're grabbing onto. You can see I even drilled a hole in it for a tie down. So your tie down hook just goes right through that when you go to tie the airplane down. And here is the little retaining pin I referred to. So your left hand is going to push this retaining pin out of the way. Your right hand is going to push that sucker into place and lock it. And that's how it works.
Okay, couple of questions from a couple of similar questions about will you ever offer a Sonex with that same similar folding wing?
If we did, which maybe, I guess the better question is, will we ever offer a two-place airplane with folding wings? In my opinion, it makes absolutely no sense whatsoever to take this Sonex and redesign it, or excuse me, better, modify it to put a wing fold mechanism in. And the reason it doesn't is there's a significant weight penalty paid to have these steel plates and this handle and these pins and all this stuff added to an airplane or a structure that already was designed to have the wing slide out. So I guess what I'm saying is the Sonex pays a little bit of weight penalty to have those long cantilevered spar tangs slide through the center of the fuselage. What would be much more appropriate is start with a new clean sheet design. That would be a two-place airplane that would have folding wings. And I think that's the answer to your question.
Okay, and Jeremy, we've pretty much hit our allotted time for this evening. Do you have a contact that you could put up on screen in case anybody? We still have a lot of questions left, and so if anybody does have a question that they desperately need answered, they should take the effort to contact you in the following way. Correct,
Yeah,
Jeremy?
yeah. I don't have all our contact information here, but I will type it real quick. The best way is to go to our website, sonexaircraft.com, and actually click on the left-hand side where you see contact, and where we have, hey, it just so happen I'm able to pull up our website right here, and
That
everybody can see
works.
it. Yeah. So in the left-hand column, when you first come to our website, you can see right here, contact. SonexAircraft.com is our URL, and you can see we just announced this new MGL little radio. We just announced, our 50th Builder Workshop. Tomorrow, you're going to see a release about the FAA NKET evaluation. But here's the best way. If you're looking for just general sales info, you click there. You'll email sales at Sonex Aircraft. If you're looking to place an order, you click here. You'll email our order team. You click here, you'll get billing questions, tech support, shipping freight, all that stuff is handled right there. So really who you contact is based on the inquiry. And trust me, I'd love to deal with and support and talk to you, all of you personally, but our business has obviously reached a point where we have to rely on our very competent and dedicated team at Sonex to support you guys and make sure that you're successful. So please contact us with any inquiry. Mark, Heather, Carrie, any of that team will be happy to get right back to you.
Well, Jeremy, thanks for a wonderful presentation. I appreciate you taking the time tonight. We had, like I said, we had over 300 people on the session tonight. A lot of great information. Don't forget, anybody that wants to see any part of this again, we will have it up tomorrow afternoon at eaa.org/webinars. And just click on the webinar archive button. And I apologize for the audio problems, but I think we pulled that one out of the fire. And do you have any closing thoughts for the group?
Well, I just really look forward to working with every single one of you. I think you're really going to enjoy this project, and you'll see the kind of blood, sweat, and tears that was put into this project, and you can see the smile on my face right up there, flying the drag gear for the first time. There's nothing like building and flying your own airplane, everybody, and if you haven't done it, I strongly urge you to do it and join the club.
I couldn't agree more, Jeremy. So with that, everybody have a great night, and thanks for tuning in. And don't forget, we have a webinar again next week. Thank you.